Hello and welcome to my video lesson 3.4b on maximizing the revenue. So this is just a couple more word problems to add to the application of quadratic function unit. So here's two questions we're going to look at. So this is the first one. A restaurant has hired you to help them choose the pricing of some items on their menu. When selling drinks, the cost of the drink is negligible to the restaurant. So far they have sold milkshakes for that much each, so $8 each. And when they sell at this price, they get an average of 60 shakes per day. They sell an average of 60 shakes per day. For every $1 increase, they sell 4 less per day. Okay, so really, let's actually use two different colors here. Really, there's an important aspect here. Okay, so this is, if you think about it in terms of like just the most basic, grade 7 or 8 level question, it wouldn't ask you all of this. It would say, what is the profit if they sold $8 milkshakes and they sold 60 per day? Well, actually, it might even be before grade 7. So profit equals the price of the milkshakes times by the number of shakes sold. So I'm just going to put number of, I'll just put number of, okay? Could be number of tickets, number of items, number of, in this case, shakes. So that's pretty simple. Let's continue and start making a true equation with this in mind. So if we think about our price, it would be $8 normally, but if we increase the price by 1, then it also decreases the number of shakes, which is normally 60, but decreases it by 4. So now we've got our price and we've got our number of shakes, and that equals our profit. Now our profit is, I'm just going to put it as y. So if we're looking for the optimal price, what we're going to do is, best bet is to graph it. So we're going to go y equals, and we can plug it in exactly as shown. So this would be 8 plus x, 60 minus 4x, bracket, and now we're going to graph this. Now, the problem is that we know we're going to have a pretty large value, but we're not going to go negative days, and we're not going to go, what's that? X value, okay, I guess X values could be negative because the X is not days, so it could be negative. But we know we're not going to go negative dollars. That would be bad if our profit was negative. And we also know we're going to have a pretty big value here, at least 8 times 60. Because they know that they can make 8 times 60. You're trying to optimize it so it's better than that. So let's get a value there, 480. Let's just go to 500, so it's for sure above that. Now let's graph it. Okay, it kind of looks close, but we want to get a little bit higher, and we want to get a little bit further this way. So this should be maybe 2, maybe make this 600, and make this 50. Okay, so we're able to see it more clearly. Beautiful. So just so you can see that window setting there, there's our graph. And so now that we have this graph, I'm just going to draw it here to the side so you guys can, so I can point at different parts of the graph. Okay, it looks something like this, right? And the vertex up here is going to give us some sort of x and y value. So let's figure out what that gives us. So second function, calc, and now we're going to find the maximum. Okay, and left bound, so we go to the left of the vertex, press enter. Right bound, we go to the right of the vertex, we press enter. Then we go to where we think the vertex is, you press enter for the guess portion, and it tells us 3.5, comma, and then 529. There you go. So 3.5 is our x, 529 is our y. Now, it says, what is the optimal price? So we haven't actually found the optimal price, have we? We have found a x value. We need to plug that x back into our red equation here. So this needs to turn into 3.5. So to find the optimal price, we'd go price equals 8 plus x, or 8 plus 3.5 in our case. So it is 11.5. So this is the price. Okay, how much more money have you helped the restaurant earn? So compared to the regular price of, this would be the regular price that they were selling at before. So at that price, it was $8 times $60, right? So it's where x equals 0. And so that was the 480, I think it was. So 8 times 60, so 480, yeah. So that's the 480, but it's asking how much more money have you earned. So 480 is the regular amount. 529 minus 480. So you've helped the restaurant earn an extra $49 per day. Not too bad, not too bad. All right. When you're selling concert tickets, the Winspear starts their ticket prices at $30 each. At this price, they sell an average of 180 tickets per show. For every $3 decrease in price, they sell 20 more tickets. Write revenue as a function of number of tickets sold. So this is a very similar question. I highly recommend you pause the video now and try it yourself. Okay, so given all of that, we're looking for the revenue, which is another way of saying profit. Okay, and we are knowing that we're going to be looking for the price per ticket times the number of tickets, right? So normally this would be R equals, and we would go price, which is $30 minus $3 times every increase, right? And then normally they sell 180 tickets, and then you subtract 20 tickets per decrease. So you add 20, you sell 20 more tickets. I read that wrong. So yeah, 20 more tickets, so you're adding 20. So this would normally be our function. Now, this is not really what it's actually asking. It says revenue is a function of number of tickets sold. So that's not really what we want. We want it to be as a function of the number of tickets sold. So N is the number of tickets. So we're going to go like this. Okay, N is the number of tickets, like that. And P is the price, like this. Okay, what we're going to do is we're going to write the function as a function of the number of tickets sold. So this first part is easy. This part can turn into, this will turn into y equals, and then the blue part just turns into an n. Okay, the question is, what is the red part going to turn into? Okay, so what we need to do is we need to rearrange this to solve for x, and then put that x value in here, and then it will be good to go. So we're going to rearrange this to solve for x. So this is going to be n minus 180 equals 20x. Then we're going to divide by 20 on both sides. So n divided by 20 minus 180 divided by 20 equals x, which could be like n over 20 minus 9 equals x. Okay, so this is what x is. So now we can plug it into this one. So substituting it in. So p equals 30 minus 3x, which is n minus over 20 minus 9. Okay, and then so this will simplify to p equals 30 minus 3 over 20n plus 27. Okay, so this can simplify to 57 minus 3n over 20. Okay, that's fantastic because now that we have that, that is the price. So I can write that instead of the whole red thing, right? So now I can write that instead of the red thing. So 57 minus 3n over 20 is that other part. So now we can multiply the n into the brackets. So we get, and let's do it in terms of this. So negative 3n squared over 20 plus 57n. All right. So hopefully this video helps you understand. Oh, and I guess I should use, instead of y is our revenue from the very beginning, right? Okay, so I hope this video better helps you understanding the maximizing revenue type questions. And yeah, good luck.